Alright, hello everyone. In this video I want to build an MCP server in .NET, connect to the cloud and do it in a way that still feels like normal software engineering. I do not want to another weather server tutorial teaches the protocol but has nothing to do with the kinds of systems many of us actually own. So instead of starting from a blank folder, I'm treating this as next branch of the same Northwind Migration Lab repo from the first month of the series. That matters because the repo already has themes that make an MCP layer believable. Typed options, clean service layer, predictable API behavior, a hot read path, and a queue-backed import theme. In other words, the hard part is not getting Claude to call any tool. The hard part is exposing a small .NET tool surface over a real business slice without bypassing the safety work we already did. So the job in this episode is simple. We will add a tiny local MCP server in .NET, expose a few order and import tools, connect the Cloud desktop over CTDO, and keep the whole thing grounded in the same modernization sample the audience already knows. That is much stronger story than, look, the protocol works. It shows where MCP actually starts to become useful. For this channel and for this sample, I would absolutely do this as a new branch in Northwind Migration Lab, not a brand new toy repo. The reason is continuity. The audience already saw this repo used to explain typed options, validation, predictable errors, queue-backed imports, and disciplined data access. If I now add an MCP server on top of the same sample, the lesson becomes much more valuable. MCP is another boundary on top of an already modernized slice. This repo also already has exact application themes we need. The API exposes orders and import endpoints. The application layer has iOrder service interface. The hot read path already has a iOrder read queries interface. The import flow already has an import queue and a background worker. That means the MCP server can reuse real services instead of inventing fake ones for the video. So my recommendation is a branch such as feature / for example week 5 MCP cloud server. Same repo, same business slice, one new process boundary. Starting from scratch is still fine if your goal is only protocol basics, but for the server the branch version is much stronger because it shows how MCP fits into software that already has a modernization story. The architecture for this episode is intentionally small. On the left, Claude desktop acts as the host or client. In the middle, we run a tiny .NET MCP server as a local process over the studio transfer. On the right, the MCP server uses the same Northwind application and infrastructure services that the HTTP API already uses. That is the key design choice. The MCP server is not supposed to bypass the application layer. It's just another caller of the application layer. It also helps to name the protocol pieces clearly. The MCP servers can expose three main kinds of capabilities: tools, resources, and prompt. For this video, I want to stay focused on tools. Tools are easiest way to make the value obvious, because Claude can call them with approval and immediately do something useful. And I also want to stay local first. Claude Desktop plus STDO is the shortest path to a real demo. Remote HTTP transport is useful later, but it adds another layer of hosting, authentication, and transport decisions that would distract from the actual point of this episode. So the mental model is simple. The Cloud Desktop, local .NET server, existing app services, real business slice. Look at the Northwind MCP server. It's a new console project separate from the API. Let's go to the programs, yes, here, and there's the database options, import options. We use the exact same services as the API, and here the MCP server. Those three lines to register the MCP server and auto discovery tool. Let's go to the order tool to get the MCP server tool type. This is an attribute, and for the methods, MCP server tool attribute. So list order summaries, get order, order import, injected dependencies, real services, not mocks. Let's go to the app settings JSON. Look, there's the database options and import options sections here. Same configuration as the API, local SQL server and Windows authentication. So that's the server setup, and now let's test all three tools. Before I scaffold anything, I want to decide what the tool surface should actually be. There is where practical MCP work separates itself from AI theater. A good first tool surface is narrow, explicit, and approval friendly. In this repo, the obvious first tools are list order summaries, get order, and queue order import. There are small, easy to explain, and they already map themes that exist in the code base. What I do not want is a giant good tool or an arbitrary run SQL tool. I also do not want a write any file tool, a dump config tool, or a delete everything tool. Those make the demo look powerful, but they create a bad engineering story and a bad approval story. My rule of thumb is to start ready heavy. Make the LLM good at asking for the right information first. Then once the trust story is clear, add a small write tool or queue tool that fits the business slice. In this particular repo, the raw summary read path is already explicit through iOrder read queries. Normal application behavior is already explicit through iOrder service, and the background themes is already explicit through iimport queue. That means the tool list is almost chosen for us. The first implementation step is intentionally boring. In the same solution, I create new console project called Northwith MCP server. Then I add the official model context protocol package and Microsoft extension hosting. In Program CS, I build normal host. I bind the same database options and import options the API already uses. I call add infrastructure so the same repositories, read queries, order service, import channel, and worker registrations are available. Then I add the MCP server itself with add MCP server, with CTDO server transport, and with tools from assembly. There is one important operational detail here. When you use stdio transport, you must never write logs to std out. Std out is the protocol channel if you write normal console output there. You corrupt the JSON RPC messages and the server breaks. So the logging configuration needs to send logs to std error. This is why I like doing the scaffold manually in the video instead of hiding behind a template. Viewers can see the 3 or 4 lines that really matter. Now I add the tool class. The csharp SDK uses attributes, so I create a class marked with MCP tool type and expose small methods marked with MCP server tool. For the first pass, I want 3 tools. The first tool, list order summaries. This is a great demo because it uses the explicit raw read path that already exists in the same through iOrder read queries. The second tool gets one order by ID through iOrder services. That shows that the MCP server can reuse the same application service contract the HTTP API already trusts. The third tool queues the legacy import by creating an import job from the configured source table and pushing it into iimport queue. That ties directly back to earlier modernization story where we move blocking work behind a queue and worker. And I want to stress one more thing here. Descriptions matter. Tool names and descriptions are not decoration. They are how Claude decides what the tool is for and when it should call it. Small names, clear words, and predictable return shapes make the whole demo work better. This is the architectural point I care most in the whole video. The MCP server should not call controllers. It should not re-implement the validation rules. And it should not duplicate the business logic just because the protocol is different. Instead, the HTTP API and the MCP server should sit beside each other and both depend on the same application and infrastructure themes. In Northwith Migration Lab, that's already realistic because at infrastructure registers iOrder service, iOrder read queries, iimport queue, and the EF core DB context, and the import worker. That makes the MCP addition look like a normal extension of the application rather than a parallel mini-system. If viewer's codebase is not structured that way yet, that is a useful lesson too. If the only way to add an MCP server is copy half of the application or call the HTTP endpoints from inside the same process, that is a signal that the composition root and the service boundaries still needs cleanup. So, this slide is really about restraint. MCP does not replace your architecture, it exposes it. Once tool class exists, the last setup step is connecting Claude Desktop. The MCP docs walk through the local server flow using Claude Desktop. The important pieces are the config file location and the MCP server JSON block. On macOS, the config lives under the library application support path. On Windows, it lives under the app.cloud path. For this .NET demo, I configured Claude Desktop to run .NET with project path passed in arguments. I strongly prefer using an absolute project path here, especially for recording, because it removes any doubt about working directory issues. After saving the config, restart Claude Desktop completely, then check that the tool indicator appears and that the Northwind tools are visible. A practical tip: .NET Run is fine for the demo because it's easy to understand. If startup gets annoying later, publish the server and point Claude at the build executable. The live demo sequence should stay very small. First, ask Claude to list summaries, then provides discovery and read access. Second, ask Claude to open one order by ID that proves the single item lookup path. Third, ask Claude to queue import that proves we can trigger a real side effect through the same queue scheme the app already uses, while still keeping the request itself small and explicit. Then harden the story. Keep logs on std error only. Keep tools narrow. Avoid arbitrary execution tools. Prefer local studio first. And if you later need remote hosting, that becomes separate follow-up using the ASP.NET Core package, HTTP transport, and map MCP. That separation matters because remote MCP is a hosting problem as much as a tool problem. Cloud managed agents, for example, connects to remote MCP servers over streamable HTTP, which is different conversation from the local cloud desktop demo. So the demo closes with the right message. The MCP practical, and it sits on top of a real seam and stays small enough to trust. It's time to live demo. Let me show these tools in action with Claude Desktop. First, we go to the terminal, and with .NET Run command, we will start our server. MCP server is starting with stdio's transport. Server is listening on stdio, ready to receive tool calls from Claude. Here is the Claude. Claude Desktop has loaded. The server should auto-connect now. Because if we go and check the settings in the developer section, I already added the Northwind.NET command, the published folder with the pure DLL here is an MCP server. So it knows Claude discovered the three tools automatically via attribute. Now let's ask a question. We can say list the order summaries to see what orders we have. As you can see, it will call the tool. Now it listing our current order summaries. It said you have 8 orders in total with status of draft. Isn't it? If we go and check the database, yes, I think he's right. You see the real order data with customer ID, status, timestamps. This query is our live database, not more. Let's test another thing. Get the first order from the list using its ID. Now I am asking Claude to fetch one order. It needs to extract the ID from the previous response and pass it to getOrder tool. So full order data include items, prices, quantities, again real data from the same database the API uses. Let's test another thing. Queue and import job and tell me the job ID. Finally, I am queuing an import job. This calls order queue order import, and I will allow, which enqueues a background job and returns the ID. Now, perfect. We have an import job. If we had a worker running, it would process this in the background. If I work according to the actual YouTube episode, I will keep the structure very clean. I would open with practical thesis, not a toy server, not a generic protocol lecture, but a real MCP layer over the same modernization sample we already know. And I would justify the branch approach. Sketch the architecture, define the tool surface, scaffold the server, implement the tools, connect Claude Desktop, and end with short-lived demo plus with few hardening rules. Like I did. That also gives several short clips for free. Why I would not start from scratch. Why I would not expose one SQL. Why std out logging breaks stdio servers, and why local stdio should come before remote HTTP. The takeaway is simple here. If your .NET application already has clear seams, MCP becomes another practical boundary, not another hype layer. And the follow-up videos are obvious after this one: MCP versus plain API integration, adding prompts and resources, hosting the server over HTTP, or connecting the same tool surface to Visual Studio and GitHub Copilot. Thank you for watching. If you like this video, please subscribe. Thank you.